Okay, here we go for the second set of questions. This is page 2 of adding and subtracting, multiplying and dividing of fractions and mixed numbers. Now, let's have a look at question 5. First thing to look at is the denominators. Are they the same? No, so we can't add them until they are. We look for the lowest common multiple of 5 and 6, which is 30. Quick tip, if one of these is prime, you can just multiply these numbers together. That's a nice little quick thing for you. So I need to make them both into 30ths. Usual method. 2/5 is how many 30ths? Well, 5 times 6, so 2 times 6, 12. If you want to do the little times 6 arrows, you can. And then let's see what 1/6 is. In 30ths, well, that's going to be times 5, so times 5 again. And there we go. So I've got 12 30ths and 5 30ths. 12 30ths plus 5 30ths is 17 30ths. And there is our first answer, a mark. Question 6, it's the same fractions, but this time we are subtracting. Now, I'm going to be a bit cheeky here. I can use what I've done already in question 5 to say that this is simply 12 30ths minus 5 30ths. No point repeating my work. As I said on a previous page, just remember that you are subtracting and not adding. So many times I've seen people do the maths really well, but just fail to get the subtraction instead of the addition. So of course 12 of anything minus 5 of them is 7 of them, and so that's probably one of the easier marks we're going to get on our paper. Now, here's question 7. Remember from the first page we realised that multiplying and dividing were, if anything, easier than adding and subtracting, simply because we don't need to worry about the denominators. To multiply fractions, I can do the numerators multiplied together. So 3 times 2 is 6. And on the bottom I could say 5 times 3 is 15. Now, of course, what I've really done is just multiply the numerators, multiply the denominators, and I could go for 6/15. That is the answer, and I will get a mark. But I want to show you just one rather sneaky thing you can also do if you spot it, which is to think that, hang on, the top has got a factor of 3 and has the bottom as well, and we could have seen that right from the start. So it's almost like I can ignore the 3's if I can divide through. 3 goes into that once, 3 goes into that once. So the top could be 1 times 2, and the bottom could be 5 times 1. Now, which is it? Well, actually, it's the same. They are equivalent. Why? Because of our good old rule. That is the same value. Look, 5 times 3 would be 15, and 2 times 3 would be 6. So absolutely go with that as your answer. It's fine. 6/15. If it asks you to simplify, then you just need to look for a common factor of 3 to get yourself to 2/5. Okay, here is question 8. Now, in the first page, we saw a fraction divided by a whole number, and I think it was 20 divided by 4. Now, in this case, we can't do 3 divided by 2. We could, but 1.5/7 wouldn't be accepted as an answer because you've got a fraction as your numerator. So what are our other options? Well, there's some really, really clever thinking here. Thinking about sevenths, then they're pretty small things. But if I've got 3 of these sevenths, now half as much, all I need to do is give myself still 3 things, but if all of those things were half the size, then I've divided by 2. So one of the really clever shortcuts you can do to divide by 2 is think, I know what I'll do. I'll make the pieces twice as small or half the size. So actually, what would be half the size? What would be twice as small as a 7th? It would be a 14th, right? So actually, I can do that. And believe it or not, 3/14 is exactly half of 3/7. So just to recap what we've just said there, to divide a fraction by a whole number, either do a division as you normally would, say I've got some pieces, I'll have half as many, or do the really clever thing, which is to say, well, I'll keep the same number of pieces, but I'll make them half the size. All right, so 3/7 divided by 2 is 3/14. Very nice.